Hello and welcome to today's PIR live event webinar brought to you by Partners in Research Canada. My name is Stacey Joyce and I will be your host. If you're joining us live, remember that you can ask questions anytime throughout the webinar by clicking the chat button in the top left corner of your screen. Make sure you change the to field so it includes everyone or attendees, and let us know where you're joining from or who in your class has asked that question. We'd be happy to give you a shout out. Today's guest is Dr. Audrey Girouard. She is an associate professor in the School of Information Technology, and she's the director of the Creative Interactions Lab at Carleton University. Thank you so much for joining us. I'll let you take it away.
Hi, so I'm Audrey, and my work is about human-computer interaction. So human-computer interaction is trying to make technology better for people, to make it easier for everyone to use their computers and think about different ways that we can do that. And I really like to sort of think ahead. I try to think of what type of technology we might use in 5, in 10 years. It's kind of hard for to think ahead that way, but it's really fun because you get to invent new technologies. And so that's exactly what I do. I try to think about what would happen if, or not if, but when our phones or devices, our tablets will be able to be deformable, meaning that they are flexible. So you'll be able to take your phone and squeeze it to answer it, or change the page in your ebook reader by sort of flipping the corner of the device itself. So there are technologies that kind of mimic more how we use current objects, and basically I try to invent a little bit of that technology and think about what is meaningful to do. So I've got a couple of things to present, and I'll start with a couple of videos, but I also have some physical prototypes to show you afterwards. So let me just share my screen with you. Here you go. So this is just a little teaser that's about what would happen if your phone could bend. So the first, there we go. So the first little video that I have is a prototype of a game. So the game is on a regular sort of rigid smartphone, and the game is called Paper Ninja. It's simply because there's a piece of paper that needs to go through a series of obstacles. And what you can see is that we put a bezel around it, kind of a case that's much bigger than a phone, and that case is flexible, and we put some sensors in the back to be able to know when the corners are detected are bent, so that when my student Eli here is bending the side, well, then the case knows that sort of the side is bent, and then can tell the game to move the piece of paper to the right. And we have sort of different types of obstacle going up and down. So that's one thing that we're looking at, into sort of what type of gestures would make sense if you have something that's deformable like that. But we really like to play with games. Not all my projects are about that, but you know, it's pretty fun and engaging. And so that led us to create another really cool prototype that's called Bendtroller. It's a bendable game controller, and it's very similar to kind of the classic game controllers, which were very rigid and flat, kind of the original ones, that we cut in half and put this flexible bridge in the middle. So you can see that we have sort of 2 boxes on the left and the right that has buttons, and those are regular buttons. But in the middle is this piece of foam that can be bent up and down, just like this, and then can be twisted as well. And you can see kind of the little things that are peeking out in the bottom. I'll play that again for you. These are, I'm trying to. There we go. You can see the like brown thing peeking up. Those are my sensors in the bottom. Again, they're bend sensors, and they're there to try to measure what I'm doing in bending. And so we have this prototype now. I'll show you what we can use it for. So you can see that we use it for arcade games. So right now we can punch by twisting it, and we can twist to rotate a piece of Tetris. And here we're controlling a continuous 3D racing game using this bendable game controller. So I will switch back to, here you go, my video. Because I want to show you, I actually have the Bendtroller here. So you can see that right now it's obviously not connected, but we have wires that would connect to your computer. And so that it could actually measure this. But I can bend in it, twist it, and I have buttons. And so my research is about trying to see whether this is a good idea. We build stuff. They're fun to build, they're fun to play with, but this is still research. And so we have to ask ourselves, is this faster? Is this more interesting? So what we did when we were playing, so we asked about 20 people to play with this game controller. They played different arcade games, and then they had to play with the buttons here that kind of work, and they had to just use the bends and the twist, and then a combination of both. And we tried sort of different ways of doing it. So maybe sometimes this was going up and down, and sometimes this was going up and down, and sometimes it was buttons that were going up and down. And we compared how people did, how fast they were at going through a level, how many points they got, how many lives they lost, but also kind of asking them how much fun they had, or any issues that they thought. And what we found is that people are really fast at pressing buttons. So way faster than doing this. And you can see, like, if I'm saying, okay, I'm going up and down, like, it takes time, as opposed to I can press very, very quickly because I don't need to move anything, or not a lot. So much faster with traditional buttons, but they had a lot of fun playing with our games. It's very novel, it's very stimulating, and that's what a lot of gamers want to think about, want to enjoy when they're playing a game. So I think it's pretty successful bendable game controller here. But what's really fun is that we build these things. You can kind of see, I'm gonna try to make you see a little bit in the middle. I don't know if you can, oh, let me see this way. I have these little things here. I have two. They're those are my bend sensors, and there's obviously some electronics that are inside here. And we 3D print these boxes on the side. So I have a 3D printer in my lab. So that's a lot of fun too. Actually, we got a new one, so my students have been really enjoying printing out all sorts of stuff. That's not always very serious, but you know, we all have fun too in our lab. And so this is kind of a little bit of what we do. I've got another prototype for you. This is not one that I showed you, but it's a small one. I also have tons of electronics inside, some sensors. It's two pieces of silicone that we 3D printed a mold, and then we poured some silicone, and this is what we get. And so with it, you can bend the corners here. We can fold it in half, kind of like, I'll show you this way. And we can also squeeze it like this so that it squeezes inside and outside. And so here, better view for bending. So this is really fun because you can do it with one hand. And this is more like what a flexible smartphone would be. And we're testing it with different users, and we're testing with people that are blind. Because you can use this prototype without looking at it, and you know where the corners are, and that's really important to cater to people that have different abilities. In this case, well, they might not have the use of their eyes, and so this could be an interesting alternative for them to better use their devices to be connected with the people they love. So this is another kind of research project that we have. Yeah, that's a little sort of overview of what I do. We build our own devices. We build sort of the hardware and the software, the games. And then most importantly, we test it. We talk to a lot of our participants, a lot of people that might be interested. We ask what they think about it. We see how fast they are, and that's what human-computer interaction is about. It's about designing good things and testing them to see whether we're right in designing our stuff.
Excellent. Well, thank you so much for showing us all the neat novel devices that you're creating in your lab and telling us why you're doing it. I think that is important too. The first question that I have for you is, what types of people do you collaborate with to do this? It seems very interdisciplinary to me, which is why I ask.
Yes, it is. So I work with a lot of different people. So in my lab, I work with undergraduate and graduate students, and they come from a lot of different backgrounds. And I find that very fascinating because I get to learn from the stuff that they know. So I had a graduate student once, a master's student that was she was an industrial designer, meaning that she really knew how to make good products. Industrial designers are the ones that design all the objects that are around you. For example, the garbage can that's nearby. Well, there's a lot of thought process into what material and what size and whether it makes it stackable. And so she brought the use of the silicone in my prototype. So kind of this thing is silicone. I didn't know how to use it, so that was really useful. I work with people that more have a psychology background so that we can run good experiments and talk to our users. We work with people that know how to design games and know how to build hardware, and we play around with all of different prototypes. So those are kind of the background of the students that are in my lab, but I also work with blind users. There's one person at the Canadian Council for the Blind, and we work with sort of different people in different companies to see what we can do for them and what they can do for us.
That's a lot of collaboration. That's excellent.
Yeah.
We now have some more questions coming in from our audience. Ms. Sacco's class is wondering if you plan on making flexible monitors in the future.
So I think they will come on the market in the next few years. Yes, that's not exactly what I work on. I use flexible displays sometimes, and but I mainly try to see, once we have them, what we'll be able to do with them. So I don't build them. There's all sorts of people who have a lot of expertise in displays. I try to mainly see, okay, if we have the technology, other than the fact that it's flexible, what can we do with this? So I think we will have some, but I think it will make it neat so that you can roll your monitor when you're not using it, for example, or you can stack them because they'll be really, really thin and lightweight. So we will have some of those in the next few years, I think.
Wonderful. It sounds like you'll have a lot to play with. Okay, well, next we have a question from the grade 5-6 students at Fossil Hill in Woodbridge, Ontario, wondering if there will be a gaming system made using the technology you showed us.
I think that would be really cool. I don't have sort of current short-term plans to make this happen. I would definitely need and somebody from sort of the gaming industry that would need to be a partner on this to make this happen. But I think it would be quite nice to actually have this integrate into gaming systems, because it could just be a controller that connects to your Xbox, for instance, sort of another version of a connector that could work with a Switch. I think it would be really cool. For now, we just make them in our lab and test it with the people that are around us.
Right. And a question here from our grade 4s at Hawkwood School in Calgary, wondering what was the first prototype that you made?
Oh, the first prototype we made. So the very first one had a flexible display, was called Paperphone. And Paperphone was the very first flexible smartphone. It wasn't sort of working independently. There was plenty of wires, and it didn't do all the capabilities that a smartphone would, but we really imagined it a lot. And so Paperphone was a lot of, was really kind of the first one to imagine what we would do with bend sensors with an actual flexible display. So it was called Paperphone. You can probably look it up and see a video of it.
Wonderful. And we have more questions coming from our class in Woodbridge, wondering if the technology you're describing is the same as what was used in the Power Glove by Nintendo.
So the Power Glove was a glove that you could detect the different fingers moving. I think they were using bend sensors, so I think it's sort of a similar technology. I'm not exactly sure, but I know every time we have sort of new students in my lab, or when I talk to people about our bend sensors, that's kind of one of the first things they want to do. Like, let's make a new Power Glove by putting sort of bend sensors on all the fingers so I can measure it. And that's something that we could do. Actually have sort of a team of students that made that one. So it's a little harder than you might think, but it's a little bit of it's kind of closer to the Power Glove, yes.
And our class with Ms. Sacco is wondering what processor the phone had. So I think they're describing Paperphone.
Paperphone. So Paperphone didn't actually have a processor in it. If you give me a second, I will show you. I'll pull up the video so I can show you if you want. I have
Sure.
it close by.
In the meantime, maybe our students in Ms. Sacco's class could tell us where you're joining from. I can't give you a shout out because we're not sure where in the world you are. And while you're searching, you can probably answer this question from our grade 5-6 class, wondering if the technology you're describing with bendable smartphones, etc., would that make devices sturdier? For example, if you dropped them, would they survive?
That would be kind of the main idea. Yes, is well, if you have something that can be curved, it means that if you're dropping it, it would survive it. So there's still some rigid components to all of these things, so it's not quite perfect yet. So I'm sharing my screen now to show you. This is actually kind of just a fun a video of just the iPhone being broken. So obviously this is not how it is, but this one is Paperphone. So Paperphone was my first prototype, my first deformable prototype. So it's really thin display that we put some bend sensors in the back, and then we did a bunch of different applications so that when you change, you press the bottom corner, then it would change the tune, or it could change the page that you're reading. It could select and make a phone call. Now, it didn't actually have all the components. It was just of a smartphone. You can see that there's wires coming in from on the left. They connected to my computer, and so I was just using my computer to run this as an application, but it was kind of really important to imagine what it would be as if it was a full device.
So if I understand correctly, you were sort of establishing the functionality of that bendability, but using an existing processor to help you test that.
Yes, because the processor is not flexible, and our display wasn't wireless.
Right. Well, just so you know, the grade 5s in Woodbridge and 6s, they want to know if you need any testers. They would be happy to volunteer and play.
Oh, we always do, but you have to come down to Ottawa because a lot of our stuff is hands-on, and so we kind of have to keep it close to the lab. Yes, you'd be welcome to if you want.
There you go. So you just have to start fundraising now and ask your teacher for a field trip. Just a little one, Woodbridge to Ottawa, no big deal. Now we just touched on this already, but maybe we can talk more in detail. Ms. Sacco's class is actually in Woodbridge as well. They were wondering if you squeeze the controller when you were talking about Bendtroller, how do you not break the components inside?
So that's kind of an important concern, right? So with our devices, there are some parts that we can bend and that we can twist, and that's fine. And then there's some rigid components, and that's kind of the one downside at the moment, is that we have to make sure that the part that we do move can move, and we don't break everything inside. So we know where you can what you can do and where you can move it, and we just make sure that our participants and our users do it correctly. And for the rest, we hope for the best and we fix it when things break.
Right. And so how many students do you have now who are essentially working in your lab?
So I have 8 people in my lab at the moment. I've got 1 postdoc, 2 PhD students, 5 masters, and 1 undergraduate student. There's also people that sort of come in and out every year that want to do small projects, but right now this is the people that I have that do a lot of the work. And so you can sort of, I opened my, I was talking to you, I opened it so you could see it inside. This is my 2 bend sensors, and they detect when I bend it in one side and the other side. And then there's kind of just a blue cap, which could be soldered on, but this part can be bent. So I can do this and that as much as I want. And right now I can bend further down simply because this whole thing will not break. But if I were to actually sort of bend it right here, then it would probably break. So to kind of go back to your previous question.
And how do those bend sensors actually work? What is happening there that's sensing the bend in the material?
Well, it's there's a few different ways that you can do this, but essentially, if you were to paint if you were to paint fabric, fabric can be stretched usually. If you're painting it, then you have a uniform coat of paint on it, which works which basically says, hey, this is flat. If you're stretching it, then the paint will kind of break apart a little bit. And that will, if you're thinking about sort of the coat of paint that's passing electricity, then as it's breaking, then there's less electricity that's going through it. And so if I'm measuring the amount of electricity that's going through, then I know, oh, it's probably being stretched out because there's less conductivity. Now, if I'm sort of compressing it, now I'll have like little wrinkles, and maybe they'll make it more conductive. So I'll have a higher amount of electricity going through, and that will say, hey, this is currently being compressed. Well, the same principle applies if you have something that's being bent this way. If you imagine I have a coat of paint here, well, as I'm doing this, then it's going to maybe sort of break out, and so it's going to be less conductive. So I can measure this, and if I'm bending it the other side, on here it's kind of compressing a little bit, so I'll have a higher value. So basically I get the different amount of conductivity, and then I get a value at the end from this, and I use that in my software to say, hey, this is bigger, this is smaller, meaning that it's bent this way or bent that way.
Very interesting. I'm picturing clothing right now, which is completely making sense to me. So thank you for that analogy. We now have another question from our grade 4s in Calgary. They're wondering what inspired you to work and research in this area?
Oh, that's a great question. I'm interested in kind of new cool technology. So a long time ago, about sort of 10 years ago, I used to do different type of research. I went and that was when I was studying in grad school. And I basically, there I found a really cool school to go to, and I started doing work on brain-computer interfaces, and that was kind of measuring brain activity and feeding it to my computer so that it would make things more efficient and more interesting. And that was just like an idea that a colleague of mine had, and I said, hey, that's pretty interesting. Why don't we research that? And then after a couple of years, I finished my schooling there, and I joined another lab, and they were doing something different, and they were playing with flexible displays, and I thought, hey, this is pretty cool. Why don't I try that for a while? And honestly, I've really liked the topic, and I stuck to it. So I've moved since, and started my own lab, and I go where sort of there's an interesting topic that that excites me. And I think research is it's really fun because it allows me to, research and human-computer interaction allows me to bridge a lot of different topics. I like to build stuff. I like to do software. So I did computer science as my before, and I did sort of software engineering as well. But I also have some artistic components. I like to do crafts a lot. And so this kind of allows me to merge all of these things together and really do things that I find quite exciting. And so that's essentially why I do what I do.
And what advice would you have for any students who, find this similarly interesting and might want to blaze a similar trail?
Well, I think you should try to play around with these with programming. There's a lot of different ways of ways that you can do that. You can learn. I know there's some courses in high school. Sometimes there's some after-school programs as well, where and you can even learn on your own. There's elements like Scratch that are web-based that you can go through and play around with this. It will really open up your creativity and your sort of analytical skills. So it's really, programming is something that everybody can do. You don't have to be to have like great math skills or to have you have to be absolutely perfect in science. It's something that everybody can do, and it's really useful for everybody. And you can play around with this. And then there's a lot of kind of science kits that are there that you can play and make little circuits. There's sort of Arduinos and Raspberry Pis and little bits, and there's a lot of different ones that that you can purchase or borrow. There, I know there's some libraries that allow you to play around with these as well, and just try to make little things. I brought a kit home. I have a 6-year-old, and he doesn't even know how to read yet, but he made a circuit, and he made a little robot that would wave because there was a motor and that was connected to a button and a battery, and it's just so creative. And he actually sort of did the craft around to make a really cool robot, and the eyes glowed, and it's something that you can do and start sort of understanding how electronics work and programming works, and it's something that's accessible to everyone. So I really recommend that you do this, because whether you end up going in business, or you end up going in science, or you end up going in child studies later on, because it's something that will be useful for all of you to do. To know.
And you're certainly not the first expert we've spoken to who has had that same sort of message of some type of programming or understanding informatics or something in that area or those areas being useful in almost every path that our students now going through school will choose. So on that note, I think we'll wrap up for today, and we will let everyone know that there are several Computer Science Engineering Week activities going on, including multiple webinars with Partners in Research Canada. So if you are looking to dive in a little with some of those things that Audrey mentioned in terms of coding with Scratch or working with some of the electronics, then do seek them out, whether with Partners in Research or other organizations as well. And before that, we have one more webinar on Canadian history, actually, a little outside of our usual STEM subjects. So you can find more information about all of that at pirweb.org. And as far as today's webinar is concerned, thank you so much to Dr. Audrey Girouard for joining us and answering all of our questions and inspiring us with what is new and coming up and what you can build when you go to work to play.